Okay, so as I said, the project Skydive was started 1 year ago at Red Hat, and we are 4 people working on it. So the idea behind Skydive is that SDN obviously is complex. There are many different types of SDN. There are different concepts. They are different in terms of implementation for the control plane, for the data path. You can even mix them together. So when it comes to troubleshooting, it becomes really hard. Sometimes you have to be very familiar with how it's implemented. It's highly dynamic. Services keeps being created and destroyed. And when it comes to the tooling for troubleshooting, sometimes you're basically stuck with the usual IP route tools, the TCP dump, ETH tool, and all the stuff, and of course the OVS command lines tools. So one of the main goals of Skydive is to make troubleshooting easier. So one of the choices that we wanted to be agnostic to the SDN, we try to do the real-time network analysis, but also post-mortem. So a typical use case is that when a user creates a VM, it has connectivity issues. The first thing it does is destroy its instance and it recreates, and that makes the troubleshooting harder. So, and one of the goal of Skydive is to be lightweight and easy to deploy, because in the case where you have production issues, it has to be really easy to deploy. Our solution to address these issues is to Skydive. It's a distributed software, so it's supposed to be running on all the nodes of your infrastructure. It's a single binary, so really easy to deploy and start. It's made up of 2 components inside the same binary. The one is the agent. Its role is to capture the network topology of a host and to do traffic capture. And then it does this locally and then forwards its topology and its flows to the analyzers, which role is to aggregate the local topologies to make a big graph out of it, and to do the same with the flows. Its role is also to do a mapping between the flows and the topology. So if we can say, okay, this flows comes from this node on this machine, and the analyzer also serves the API. So to build the network topology, we make use of different sources. The first one is OVS, using OVSDB. We are notified of the creations of every bridge port interfaces by OVS. We also make use of netlink for other network objects. So we get notified from the interfaces, the bridge, the bonds, the tabs, the VLANs, and stuff like that. We, using ETH tool, we get properties of those interfaces. So typically the MAC address, the IP, the MTU, the statistics, or the number of packets sent and received, the errors. We also listen for creation and deletion of network namespaces. And we also allow the creation of the registration of static objects like a top-of-rack switch using the configuration file. We also make use of external connectors to get more information about the network objects we have. So we have connectors for Docker, OpenStack Neutron, OpenContrail. So, sorry. So the idea is that when we see a new interfaces coming up or a network namespace, we are able to make the connection between, for example, a network namespace, this belongs to this container, or this DHCP in the case of OpenStack. And so with all this topology, we create a graph where the nodes are interfaces, network objects. We put metadata on these nodes, so the statistics, the MTU, the IP address, and then we create links between those nodes. There are different types of links, L2, ownership, membership, and you can even add your own if needed. So at the heart of this topology feature is a graph engine. We have different backends for graph database. So we support Titan, Neo4j. We also use non-graph database, but we have a backend for Elasticsearch. This is event-based, so you can be notified of all the events of the graph. The web UI makes use of this mechanism. And to issue queries on the graph, we use the Gremlin language, which is a graph traversal language that was created by Apache Tinkerpop. So it's a custom implementation. We added a few steps that were relevant to Skydive. And one interesting thing is that we keep the full history of the graph. So every time a node is created or deleted or modified, we keep the old version so that we are able to recreate the graph where it was at a specific time. So this is, well, the formatting is awful, but yeah, this is a typical Gremlin query. In this case, it simply asks all the interfaces that are connected to an OVS bridge called brint. And you could do this for example, to detect configuration errors, like give me all the interfaces that have an MTU less than a specific value. So now a brief demo of the topology feature. So in this case, we have two VMs with a Skydive agent. On each VM, I will create they have two physical interfaces connected to a top-of-rack switch. We create a network namespace, a pair of VETH. Both are connected to an OVS. One VETH is connected to an OVS bridge. And finally, we have a GRE tap interface for a tunnel between the nodes. So I hope you will be able to see this. OK. So you will see the interfaces on the analyzer. So you will see the first node starting up and all the different objects and the nodes created. So the first block here is the first node, and the second one here. And this is the namespace, and this is the top-of-rack switch that links those both nodes. So you can move your mouse on every node and get information about a specific node. So that was for the topology demo. So now we will talk about the flow aspect of Skydive. First, what we call a flow in Skydive. So for every packet, we create an object called flow. We take a look at what the packets. So we only look the link, the network, and the transport layers at this time. We extract the source and destination. So for it, the MAC and the source MAC and the destination, the IP source, the ports, and we do a mapping between the nodes of the topology. We also keep the metrics for these flows and the number of packets, the number of bytes. For each flow, we compute two IDs. The first one is the ID. It's a unique very unique ID. So if we see traffic from a SSH session on different capture nodes, for every capture node you will have a different flow with a different ID, but they will all have the same tracking ID that allows us to recognize this is the same SSH session. So, and it's useful when you, in the case of when the packet is encapsulated. So we'll have both two flows, one for the inner and one for the outer packets. And the tracking ID will allow you to follow traffic inside the tunnel. So speaking of which, we support GRE, VXLAN, MPLS, and GNAV's support is on the way. So to actually capture the flows, we have the different techniques. For OVS, we use the S-flow. For other interfaces, we use AF packets. We also support LiPCAP. We have a probe on the way for eBPF, so I think that you're all familiar with what eBPF is right now. So this is mainly for performance, so we do exactly the same. We keep a local flow table using eBPF maps, and we synchronize with the agents at periodic time. There is also work going on to support NDPI, so for enhanced classifications of packets. So this is the flow, how a capture is actually done in Skydive. So first you have to define a capture using a Skydive API. You specify a Gremlin request query, so it could match one node or a set of nodes. The agent is notified that a capture has to be done. It creates using the appropriate probes, or OVS or AF packets. When it creates or updates flows, if there is already a flow existing for this packet, it stores this into a local flow table. And it periodically sends those flows to the analyzer using a protobuf and a UDP. The reason why we do this is that the analyzer has a global view of all the network topology, so he's able to map a MAC address with a specific node in the graph. And so once this mapping is done by the analyzer, it stores it into a database, so typically Elasticsearch, or we also support OrientDB. So to issue queries on the flows, we use the very same language and then for the topology. So this is the Gremlin language again, and we also have the full history of the flows. So here is some examples of Gremlin query. So the first one, it assumes that you have the tracking ID of a flow, and it gives you all the nodes, all the capture nodes where this flow has been seen. The second one is the same, but not with a tracking ID, but with an IP source. And the last query is make use of the history. So you can have the number of flows that were active on the BR int bridge 1 hour ago. So this is, at this time, Skydive can be really seen as a toolbox. So you can imagine different use cases. The first one, obviously, is the troubleshooting. You can see where your packets are dropped, where it can be when they are fragmented. There is fragmentation, sorry. Another use case is validation. So for example, it could be useful to ensure that an OpenStack deployment is working correctly. You could also use this to detect bad performance or congestion points. And also, of course, for the post-mortem analysis. You could also use a Skydive for monitoring. We have a Grafana plugin. So using the very same language, Gremlin query, you can ask to graph all the traffic for a specific tenant, in case of OpenStack, or for a specific kind of traffic, like HTTP. We also have basic support for alarming, so you can be notified. Okay. For example, when an interface goes down, or if a flow exceeds a certain amount of gigabytes, for instance. We have contributors that were interested in capacity planning. So their idea was to be able to schedule services on nodes with the lowest latency. So they are writing a filter for the OpenStack Nova scheduler that calls the Skydive API to get this information. And well, you could think about using Skydive for billing, for instance. So now I will show you a brief demo regarding the flow feature. So we'll use the very same topology than the previous demo, so the two agents and the topology we saw. We have a GRE tunnels between those two nodes. I will create capture points, generate traffic between those two nodes, and we'll see that we are able to follow traffic inside the tunnel. Okay. So this is the very same topology, and we'll generate traffic between the two namespaces, so the two VTH. We'll see that the traffic will go through the GRE interfaces, and finally, on the physical interfaces, the ETH1 of both nodes. So for this, I will define capture. So I can select 1 point or 2 points, and it will create captures on all the paths. So sorry, it's a bit, I have to create four capture in this case. Okay, you can see there should be a small red sign saying that the recording is enabled. Okay, so now I have all my capture defined. It takes some time for the, yes, okay, it's working. And then I will use the packet generator of Skydive. It's a really basic one. It's a very early implementation of this, so we only support ICMP requests. So I'm going to select both ETH in the namespace. I inject a few packets, and you see at the right, I can see that I saw 4 packets, and it should highlight all the nodes where this packet has been seen. So it's in yellow. So we can see that the traffic has been seen, of course, in the VETH, but also in the physical interfaces. So even in the tunnel. Okay, so if you want to start to try Skydive, it's really easy. As I said, it's a single executable. So and it also provides an all-in-one mode. So by just executing this command, you will have both an analyzer and an agent running on a machine. So it's really easy to set up. We have a DevStack plugin. So only 2 lines, and you will have your DevStack running, but with Skydive enabled. We have a Docker container and a Docker compose service, so it will create one container for Elasticsearch, one for the Skydive analyzer, and one for the agent. And we also have a Kubernetes service, so it's the same then for the Docker compose, but it will spawn an agent on every node of your Kubernetes cluster. So Skydive is open source. It's licensed under the Apache license. We have a GitHub page, but so you can file issues on our GitHub. But we use another project for code submission, which is based on Gerrit. But this is explained in the documentation. Skydive is written in Go for a different reason, for performance reason, for deployment reasons. And there is, I said good, I don't know, but for such an early, such a young project, the documentation is okay. So hopefully you will. The Gremlin syntax is described there. You have the Quickstarts, the integration with OpenStack, quite a bunch of information here. So your contributions are more than welcome. We are very happy to have contributors from IBM or Orange, and so this is really exciting. And if you have any questions, I will be happy to answer them.
All right, let's thank our speaker.